am Dr. S.K. Tamrakar from Bhartiya Group of College, Bhartiya College of Agriculture Engineering. I am taking Engineering Mechanics, and today's topic is free body diagram. Free body diagram. Free body diagram. If a body is so near like this, any ball is here resting in the plane, this will act a weight W downwards of this ball, and we have to make free body diagram by replacing this field with the reaction. So the free body diagram of this ball is by replacing this ball and this ground field. Both the weight of ball is downwards and the reaction is acting upward. So this is the free body diagram of this ball. If number of balls are spheres are put in a cylinder, number of balls are there. If 2 balls or cylinders are put in a channel, one is here and other is here, then the contact point, if this point is A, this point is B, this point is C, this point is D. In this case, the weight of balls act downward. This one is W1, this one is W2. Then for making the free body diagram, we have to replace this channel and then these 2 balls. If we take this first ball, ball 1 and ball 2. If you want to draw the free body diagram of ball 1, then the reaction from E, RA is here, RA is acting here, W2 is weight working downwards, W2. We have to replace this channel and this ball, both we have to replace. Then here connection D, at D connection the ball 2 and ball 1. So this ball 2 act reaction to ball 1 and this ball 1 react to ball 2. So here at ball 1 the reaction from ball 2 is RD. This is the reaction from ball 2. This is the free body diagram of ball 1. Now if we want to make the free body diagram of ball 2, then that is also very easy. Here W1 weight acting downward, then reaction at RB acting upward, and this C reaction RC acting from this side, and the reaction of ball 1, this reaction opposite to this RD comes here, this reaction is in opposite direction RD. Like this we have to replace all the supports and we have to give the reaction for that support. This is the free body diagram. We can also take some more type of examples for taking the free body diagram, or sometimes some tension is also there, some internal force, external force are there. So we'll just discuss this internal and external force. internal force. If a rod is here and some force is acting, in the rod, then inside of the rod here also some force act here in this direction and here in this direction, that is equal to this force F, and this one is equal to this force F. Because of the internal points of this rod, the material that gives the force internally to the rod, and this force will accommodate by this force, and this force is accommodated by this force. So inside any component, if there is some particles, then with the effect of this particles attraction, this type of force are there, that is the internal force. Next is external force. External force. If one ball is here and some effort is there, P, then weight is also there acting here, reaction is also here. So here the external force, this force P is external force working outward to the body. This weight W, this is also an external force because this is also acting outward, and some reaction is there, that is also outward forces. So you can find the internal and external forces very easily. Then next are the type of tensions in different type of parts. If any weight is lifted with the ceiling, then there is some tension in the string, tension in this string. If the weight is lifted by combination of two strings from the ceiling, then here if one knot is here, then this one is T1, this one is T2. They are different because of this length may be different, and here this tension is T3 for lifting this load. This type of tensions are there. Then if some pulley is lifted here, pulley is here and some weight at here, so here the tension T1, in this side also in the pulley the tension in different side is different. W2, W1, the weights are different, so due to the friction in the pulley, these tensions are different. Then next we will study the sign law, or that is also called Lemmies Principle. sine law, or this is also called Lemmies Principle. If three forces are there, F1, F2, F3, and the angle opposite to F1 is theta 1, angle opposite to F2 is theta 2, angle opposite to F3 is theta 3. Then according to this sine law, this force F1 by sine of theta 1 is equal to F2 by sine theta 2, and that is equal to F3 by sine theta 3. Sometimes using this equation is easier as compared to resolving the forces. If three forces are there, then this equation gives quick result. Numerical, this thread is tied here at point A, making 30 degree with the vertical plane. Then two load of 2500 are there at point B and C. The angle of tie T2 tension with vertical is 120, and at point C this angle is 60, and this angle is vertical wall is also 60. Now we have to make the free body diagram of point B. For making this, we have to make the body free from forces. Only we have to show the forces here. These are the forces, 2500 Newton, and this one is T2 is 120 from here, and this one is T1. This angle is 30, so this angle is also 30 degree. Okay, then this angle is total 120, so this is 90, this is also 30 degree for this T2. Now making the summation of horizontal forces, Fx equal to 0 by equating here the Fx here. This T1 is in this direction, T1 sine 30 minus T1 sine 30, and if we take T2 in this direction, that will be good. T2, then T2 cos plus T2 cos 30, that is equal to 0. So this T1 sin 30 equal to T2 cos 30, T1 equal to T2 cos 30 by sin 30. After this, making the free body diagram of point C. Free body diagram of point C, at C point this angle is T2 with this one is 60 degree, this 2500 Newton, and this one also T3, this angle is also 60, this angle is also 60. So here making the equation for this horizontal forces, Fx equal to T3 sin 60, T3 sin 60 minus T2 sin 60 equal to 0, and here if we have to also to calculate the for point B the summation of Fy, also we have to calculate. Fy is Fy equal to 0, so this for finding out the Fy, that is T1 cos 45 cos 30, this T1 cos 30 in this direction, and T2 we have changed the direction T2, so this is also the Fy, summation of Fy, that is T1 cos 30 minus 2500 minus T2 cos 30, the T2 sin 30, T2 sin 30 equal to 0. So here putting the value of T1 equal to T2 cos 30, so that is T1 cos 30 minus T2 sin 30 equal to 2500. Putting the value of T1 from equation 1, T2 cos 30 by sin 30 into cos 30 minus T2 sin 30 equal to 2500. So the value of T2 comes 2500 Newton, and putting the value of T2 in this equation, this T1 comes 2500 cos 30 by sin 30. So this value of T1 comes 4330 newtons. And here by cancelling here sin 30, sin 60, both T3 equal to T2, that comes 2500 newtons. So this type of solving is very easy. You have to practice more and more in this type of questions.